Hello everybody and welcome back to the DCAC channel, where in this series we kind of practice to solve technical interview questions on the spot. Let's pick another question, shall we? I was kind of sticking to this page. I think I'll just move one page further here. Intersection of two arrays. I think this will be very easy. Given two arrays, write function to compute their intersection. This will be a very easy, let's see, each element in the result must be unique. The result can be in any order. So while this is a very easy question, I guess there is, yeah, this is very Googleable. Let's put it that way. You can definitely, I'll even show you what you're going to be doing. You'll be doing num1, basically set of num1 minus set, well, actually you want the intersection, right? This would mean that you are getting anything that's in both, and just returning each element in it must be unique. It means you're also removing all the duplicates. So basically this. Now I'm just gonna solve it anyway. Nums. Sorry. I'm just gonna solve it for you guys, but we're gonna move to something better. Yeah. This is this type of operation, or for example, you can also do the difference, not the intersection. This type of operations you can do on sets only in Python, just so you know. But yeah, let's I'll even submit this one, but let's move to something better. All right. Duplicate zeros. That sounds interesting. Let's see. Do not return anything. Modify array in place instead. That's interesting. Cool. So 1089 duplicate zeros. Given a fixed length array R that has integers, at least that's the suggestion, of integers, right? And it's a fixed length. Duplicate each occurrence of 0, shifting the remaining elements to the right. Oh, that's interesting, right? I think we've done something similar previously, so it wouldn't be that hard, but this is good practice. Note that elements beyond the length of the original array are not written. Oh, so basically, if you had an array of 10 elements and you had to double 1 0 somewhere in the middle, the element that was on the very last position has to be dropped. So do the above modifications to the input array in place. Do not return anything in your function. That's also interesting, right? That's something that I'll have to think about now in because in place, I'm not sure how to do this on like just using basic Python operations. That's interesting. So our input, when we have an input like this, the output of course is 0, but after calling your function, the input array is modified to this 0 is now 2 zeros, and we're pushing. What that means is when I'm, for example, if I were a human, if I were to do this in the physical realm, let's put it that way, I would basically split both parts, right? Like this and like this. I would add another 0, and from this one I would just remove a 0 and just add what, or not remove a 0, remove the last element, and then add what's here that's left to the remainder. Now, can we do anything like this in place? I mean, you could theoretically in place. It would mean that you're basically pushing everything one index further. I'll have to quickly Google how to do in place operations on arrays. So I was gonna Google this, but then I thought about it, like the suggestion was something like append, and just to think about how an append would work in our case. If we have this array here, we start and we look like index 0, it's a 1, right? And index 1, we see that there is a 0. What that means is that we could have something on the side that will save us the 2, like on the side, and then it will append. How would you be appending? It would be an insert operation, I guess, right? List.insert at the index, shifting elements to the right. So yeah, this is the only thing that we'll have to be doing here. So let's quickly check it just to make sure. So we have a list, and what was it? Insert, and we say we want to insert at 0, 1 at an index 2, and we'll do a 0. And of course, let's have it as a variable. Was it R? And then just print it. And the reason we got the none was because basically this operation will return nothing. We actually have to do it like this. Like this operation returns nothing. But that's why we have to assign it like this, then in place, insert, and yeah, that's all we need to do, and we see that it's doing it. So what we have to do is keep two things in mind. The first thing in mind is to actually know how long array length. And why do we need to do this is because at the end, so now we'll be appending every time, and our list will always grow, but we want to cap it at a certain length, and this certain length is basically this. So we keep the length at the very beginning, and now we only do for element let's just keep it the full name, for element in enumerate array. If element is equal to 0, we will be doing array insert, and of course here we want the index as well. For index element in enumerate array, if our element is a 0, we'll be inserting at the index plus 1. So basically, if we are at this index, we want to insert the 0 at the next index. I guess you could also insert it here, but I would do, if I were to do it in a physical world, of course I would insert it in the next position, right? So that's why I'm doing it like this. And yeah, this is all, right? And at the end you'll have inserted all those stuff, all the zeros, and now we want to return our array. Oh, we are not returning. How do we cap? I guess here maybe. What we could be doing is every time we insert, also we would be popping, and it would be at array length. And why this would work is because this is the very last, basically this would not have been an index at the very beginning. Like for example, we have 2, 4, 6, 8 elements. The last index would be 7, but this would be 8. So this would indicate us something that's outside, but in our case we are adding one element here, so our array is one more anyway, so we're getting exactly this index to pop. So we are popping the very last element. Our array returns to the normal size for every 0 that we double, and this is the this is what we are looking for, right? In this case, we doubled once, we removed one element. Now we went here, no zero, no zero, one more zero, we double once, we remove one element. So basically these guys plus the duplicates, exactly. Here we do nothing because like we don't double because we don't find any zeros. The length of the array would be up to like from 1 to 10,000. These are the numbers, are basically single length digits. Okay, so many hints for something like this. That's hilarious. Let's see, do we get it? Insert, of course, at the index we would be inserting a 0. Sorry for that. Let's see. I guess it wouldn't make sense because then I'm looking at the next index, right? I mean, it wouldn't make sense to update one more because yes, a human, you would do that, but then the next time you would, like when you put the second 0 here, you would basically look and see, okay, now this 0 I already took care of it, I have to look for the one afterwards, right? So that's why I'll just be updating at the same index position. But yeah, this would still mean that the next one is skipped. Oh shit. How would I do this? Now what I could do is basically have a separate variable that would say skip next, and it would be, for example, false. And if I do this, and I'll still keep it like that, I would say skip next would now be true. And in every iteration, at the very beginning, we say if skip next is equal to true. Then we make continue, which would basically skip this iteration. And before we do this even, we would say that skip next would now be false because we have jumped over the 0 that we just replicated. And we are looking at another one, right? And we have to reset our kind of like thing that keeps us to like that reminds us to skip one iteration. This is the one skipped iteration. Next time it will be again false until we find a 0. We add it to the next iteration, we put it to true. The next iteration we see it's true, we reset it and we skip. Now this should work. And as you can see, it works, at least for for this example. Let's try the 1, 2, 3. I would also try something that's like what if you had 1, 0, 0, 0, well, 0, 0, 0. What would that do? That would basically just leave it as that, just like it is, but it also has to keep the length. And as you can see, it keeps the length. Do we have anything else? And I didn't really like that I had to use this thingy here. Maybe there is some better way of approaching it. That's the only thing that I cannot really mess with the indexing because I don't know how enumerating would work afterwards. If you increment the index, you know, will that still continue to work as intended? Let me quickly Google that. Okay, so I did some reading. It is actually pretty cool. I mean, it's still not perfect, but it's actually pretty cool. So the where was that? Was here, right? Not this one. I think it was this one. Well, the explanation was that when you create an iterator, like such as, for example, an enumerate iterator, it will create something like, basically it will return an object that is iterable, and as you can see, it is basically mapping. You can map them exactly how when you're doing this operation here, like index element, it will look at exactly the index and the element. So basically you're mapping those when you're writing it like this. The object is being created, but it's not being stored. So the only thing that we need to do is actually have our iterator, and the iterator will be the same enumerator here. So if we store it as an object, and now we just call the index element from the iterator. As I said, the elements will be exactly mappable as before. And now we basically don't need to do anything of this. The only thing that we need to do is basically, okay, we will put the next 0, like the added 0 on the next index. We will pop the last element, and we will call next out of the iterator, which will basically switch the iterator one level higher. And this is exactly what we achieved with our other approach, I guess. And I have messed up with something, I guess. So I'm assuming what happened is that basically we're trying to, like when we are at the very last element, we're still trying to skip to the, and this would be for a case where we end up on a 0, I guess, right? In this case, let's quickly remove this one, and I think we will see that, yeah, our code now runs because there is no 0 at the very end. And that means we are not trying to skip to something that's not existing, like an index. Like this will try and search for a further index, which will not exist, right? So this would mean that if index is basically at the very edge, and that would mean our index is like that. It's basically the last index. If not the case, then we can do our skipping stuff. And I will quickly check against our original case, just so we don't confuse ideas. And yeah, it works. And now let's put the more complicated scenario. And yeah, I'll have to wait now. Let's see. And yeah, it is accepted. So pretty cool. I mean, it's not the best, but just storing the iterator as a variable gives you a great deal of flexibility. In this case, it didn't really improve readability that much, but I would say there will be applications where this would definitely benefit you. Just the extra control that you have over the iterator, right? So yeah, talking about runtime complexity, I mean, we are only running once over the array, and that would be like the worst case scenario would be the amount of the array. We are doing single operation here, and I mean, the insert operation may be a bit more taxing. This is something that you have to kind of mention at the interview, that maybe there is something more here. So it would be something like n times whatever this costs. This would probably be nothing. That will be just one operation, because we are popping the very last element anyway. We are not rearranging the array. And yeah, like this thingy here, again, single operation. I mean, this basically saves us steps, right? So in terms of runtime, I would say it would be n times whatever this thing is when it comes to cost. And for space complexity, I guess we are not doing much, because we only have an iterator, we only have a variable here, and the other thing that's big is actually growing is the array itself. So this would be n times n for the space complexity, and yeah, that's all. Let's submit it and see if we didn't miss something, because I did talk a lot, but I didn't really run it, right? Or submit it. And yeah, it looks like we passed, and actually pretty good. So I'm quite happy with that. I hope you also are satisfied with this solution. I learned a lot, like just, again, doing the enumerator stuff, and just something so simple, just like add an extra 0 and keep the length array. It can actually get complicated. I thought it would be very trivial, but it turned out it's actually a pretty interesting Yeah, pretty interesting problem to solve. So that was it from me. I hope you liked it. If you are new to the channel, maybe consider subscribing, and see you guys next time. Bye bye.